there's a huge emphasis on genomics and how it's going to change the way that we do breeding and all you know, it's really the future. But really we still need to be able to deliver genetic gain directly into farmers' fields. And genomics is one of the tools that we have to enable us to do that. And I think it's really important to recognize that genomics is a tool in the toolbox and that it's not going to replace a breeder making a selection or a yield plot or assessing how a variety performs in the field. But it is a great resource and it gives us a new level of precision to be able to make a decision or select something more reliably and hopefully faster, so that it can mean that we can get things into the field to be tested much more quickly. I think a really important role for the CG is really delivering genetic gain to farmers in the form of advanced varieties or breeding material. And I think that role is really important, particularly in the developing world, to make sure people have equal access to new innovations through the varieties, the seed that they can buy or the varieties that they can sow in the field. And I think genomics is a great route to get there, but whether you invest in actually generating that genomics data or invest in how you use it, a lot of that's a practical limitation, understanding how you can use those markers to make a selection decision and to move material forwards. And I think even beyond the CG, in many small breeding programs, the reality is that you still use only a handful of genetic markers. So we might have a whole genome sequence, but we're still only using a handful of genetic markers. And those are to select on relatively simple single traits, so disease resistance or a quality attribute. So I think there is a disconnect between the number of markers that can be reliably used in a breeding program of a reasonable size and this huge genomic coverage that we have from whole genome sequencing. And what we need to do is to bring the price point down and work out how we use that genomic information reliably in breeding programs. I mean, the cost of these marker technologies and genomics is coming down, and people say, you know, I can sequence a genome for $1,000, and then you think, yes, you can do that, but how does it relate to the yield that you're going to see in a field? And I guess if I had the money, I would probably say we need to look at more of the material in the field. So we need to make sure that we're getting large populations of individuals into the field so that when we apply the markers, we can use them to make a selection decision which is based on the actual performance of that material. So I think it's dangerous to say that we're going to replace those breeding decisions entirely with marker information, because we need to understand how the material behaves in a given environment. So there's definitely a balance to be struck between how you would spend your $100, whether you invest, how you allocate those resources most effectively over the breeding program. And of course some of that will go into markers, but we still need to be testing the material in the field in the national program and understanding how our selection decisions are changing the varieties and really delivering that genetic gain and the benefit to farmers who are growing them. I think that time span question is what we're really working on as researchers, and I think that's really one of the things that we need to focus on, is really narrowing the gap between the time that we spend thousands of pounds to sequence a genome to when we see that innovation or the outcome of that innovation appearing in a farmer's field. And I think the wheat genome is a great example of that. So we've only very recently 200 scientists, loads of funders and different organizations contributed to a high quality wheat genome assembly. And that's a brilliant resource and a great investment. And now people are using that to do things like very rapidly clone rust resistance genes. So it's in using that huge resource that was developed by a lot of people over a lot of time to really try and get down to the gene level very quickly and then develop a marker and give that to a breeder to use to make a selection decision. So I think that's the thing that's going to change, the speed to application once we have the resources in place. So I think optimistically you could see a genomic advance that's discovered now, hopefully in a breeding program in 5 to 10 years. And I think that's an area that we as researchers really need to focus on, narrowing that gap between when we generate a huge and really useful resource to showing that it can be applied and used in a breeding program to deliver a new product to a farmer.